Hi and welcome to this video on the quotient rule. This video is primarily aimed at students revising for their A-level maths and or further maths exam, as well as students preparing for or partaking in a STEM-based degree. If this is the first video from my collection that you're watching, you may want to take some time to watch my introductory video. This should give you a better idea of how to get the most out of these videos. So what is the quotient rule? The quotient rule is used to differentiate two functions where one has been divided by the other. I.e., we are differentiating something of the form y equals u of x over v of x. Here, this notation shows that both u and v are functions of x. But what actually is the quotient rule? The quotient rule states that dy by dx equals v du by dx minus u dv by dx all over v squared. Here, du by dx represents u differentiated with respect to x, and dv by dx represents v differentiated with respect to x. Let's move on to our first example. We want to differentiate y equals 4x squared divided by 3x minus 7. And we want to differentiate this with respect to x. Here it helps to write out what u, du by dx, v, and dv by dx are. So in this case, u is 4x squared, as it is the function on the top of the fraction. Du by dx is u differentiated with respect to x, so in this case it equals 8x. V is the fraction on the denominator, which is 3x minus 7. So dv by dx is just 3. So using the quotient rule that we have at the top of the page, we can substitute in these values and work out what dy by dx is. So dy by dx is equal to 3x minus 7 times 8x minus 4x squared times by 3, as this is v, 3x minus 7, times du by dx, 8x, minus u, 4x squared, times dv by dx, 3, all divided by v squared, which in this case is 3x minus 7 all squared. You don't normally need to expand the denominator, so we can leave that as it is, but we can obviously tidy up the numerator. So we can simplify this to be dy by dx equals 24x squared minus 56x minus 12x squared, again, all over 3x minus 7 all squared, which we can simplify again to get our final answer of 12x squared minus 56x all over 3x minus 7 all squared. Moving on to our second example. Again, we want to differentiate with respect to x, but this time we're differentiating the function y equals 5x cubed minus 3 divided by x to the power of 4 plus 2. In a similar fashion to the previous example, I'm going to write out what du by dx, v and dv by dx are. So in this case, u is 5x cubed minus 3, as it is the function on top of the fraction. Du by dx is u differentiated with respect to x, which is 15x squared. V is the denominator, so x to the power of 4 plus 2, and dv by dx is v differentiated, which is 4x cubed. Now, using the quotient rule, we can work out what dy by dx is. So we get that it is x to the power of 4 plus 2, which is v, times 15x squared, which is du by dx, minus 5x cubed minus 3 times 4x cubed, all divided by v squared, which is x to the power of 4 plus 2 squared. Again, we can expand the brackets on the numerator, which gives us that we have 15x to the power of 6 plus 30x squared minus 20x to the power of 6 plus 12x cubed, all divided by x to the power of 4 plus 2 all squared, which again I will not expand. We can then simplify this to get our final answer. dy by dx equals minus 5x to the power of 6 plus 12x cubed plus 30x squared divided by x to the power of 4 plus 2 squared. Moving on to example 3. Again, we want to differentiate with respect to x, but this time our function is y equals 1 minus 2 ln x, where ln x is the natural logarithm of x, divided by x to the power of 4 plus ln x. As before, I'm going to split this into u, which is 1 minus 2 ln x, which differentiates to be minus 2 over x, and v is x to the power of 4 plus ln x, which differentiates to be 4x cubed plus 1 over x. Again, we can use the quotient rule, which is dy by dx equals v, so x to the power of 4 plus ln x, times du by dx, so minus 2 over x, minus u, so 1 minus 2 ln x, times dv by dx, which is 4x cubed plus 1 over x, all divided by v squared, so x to the power of 4 plus ln x, all squared. We can then expand the brackets to get dy by dx equals minus 2x cubed minus 2 over x ln x minus 4x cubed minus 1 over x plus 8x cubed ln x plus 2 over x ln x, all divided by x to the power of 4 plus ln x, all squared, which again I will not be expanding out, which we can obviously simplify to get dy by dx equals minus 6x cubed minus 1 over x plus 8x cubed ln x, all divided by x to the power of 4 plus ln x, all squared. We can then factorise the numerator, so we get dy by dx equals 2x cubed 4 ln x minus 3 minus 1 over x, all divided by x plus 4 plus ln x, all squared. But we don't really like having this 1 over x term in the numerator, so we should make that x appear in the denominator, so we need to multiply the top through by x to bring the other x down. So this leaves us with our final answer. Of dy by dx equals 2x to the power of 4, 4 ln x minus 3 minus 1, divided by x to the power of 4 plus ln x, all squared. Moving on to example 4. This time our function involves trigonometric functions. So we've got y equals 6 sine x divided by 9x plus tan x. And we want to differentiate again with respect to x. So let's work out what u, du by dx, v and dv by dx are. So u is 6 sine x, du by dx is 6 cos x, v is 9x plus tan x, so dv by dx is 9 plus sec squared x. Using the formula for the quotient rule, we can work out that dy by dx is equal to 9x plus tan x, so v, times 6 cos x minus 6 sin x times 9 plus sec squared x, all divided by v squared, so in this case 9x plus tan x, all squared. Again, I won't be expanding the denominator, but we can expand the numerator. So dy by dx equals 54x cos x plus 6 sin x minus 54 sin x minus 6 sin x sec squared x, all divided by 9x plus tan x squared. This can then be simplified to our final answer of dy by dx equals 54x cos x minus 48 sin x minus 6 tan x sec x, all over 9x plus tan x squared. Some of you may be wondering where the tan x sec x term came from. This is just sin x sec squared x simplified. The numerator could be factorised to make my answer seem cleaner, but I will leave it at this for now. Example 5. This is the last example that I will go through. So let's look at the function y equals x squared ln x all divided by x to the power of half, so the square root of x, plus 4. Again, here u equals x squared times ln x, so du by dx equals x plus 2x ln x. If this isn't obvious to you, you may want to check this using the product rule. V equals x to the power of half plus 4, and dv by dx equals a half x to the power of minus 1 half. So, using the quotient rule, we get that dy by dx equals x to the power of half plus 4 times x plus 2x ln x minus x squared ln x multiplied by half x to the minus 1 half, all divided by x to the power of a half plus 4 all squared. Let's expand the brackets on the top. From this we get that dy by dx equals x to the power of 3 over 2 plus 2x to the power of 3 over 2 multiplied by ln x plus 4x plus 8x ln x minus a half times x to the power of 3 over 2 ln x, all divided by the square root of x plus 4 all squared. We can then simplify this further to get the final answer that dy by dx equals x to the power of 3 over 2 plus 3 over 2 x to the power of 3 over 2 ln x plus 4x plus 8x ln x, all divided by the square root of x plus 4 all squared. We'll move on to 2 further examples that I will not go through. Instead, this is an opportunity for you to have a go. I'll write up 2 questions. After writing each question, I will give you 5 seconds, after which the answer will be revealed. So for both of these, we want to differentiate with respect to x. So question 6, we want to differentiate with respect to x the function y equal to 1 plus e to the x divided by x to the power of 6 minus e to the power of 3x. 5, 4, 3, 2, 1. So the answer to this question is that dy by dx equals e to the x, x to the power of 6 minus 6 e to the x times x to the power of 5 minus 6x to the power of 5 plus 3e to the power of 3x plus 2e to the power of 4x, all divided by x to the power of 6 minus e to the power of 3x, all squared. Last question. Differentiating with respect to x, this function y equals 5 to the power of x divided by 5 to the power of x minus 2 to the power of x. Here, recall that d by dx of a to the power of x is a to the power of x log of a. 5, 4, 3, 2, 1. The solution to this question is that dy by dx equals 10 to the power of x of log of 2 minus 10 to the power of x times log of 5, all divided by 5 to the power of x minus 2 to the power of x, all squared, which you might have also written as dy by dx equals 10 to the power of x times log of 2/5 divided by 5 to the power of x minus 2 to the power of x, all squared. Thank you for watching my video.